Continuing with the derivative series, we're going to be looking at the product rule now. And here, as the name implies, we will be multiplying the parts of a function in order to get the derivative, okay? So to solve this, you take the first part of the function and multiply it by the derivative of the second part. Then you want to add all of that to the second part of the function, multiply by the derivative of the first part. So let's look at some examples so you can see what I'm talking about. So in this first example, this is our function, and here we have 5x squared times natural log of x. And so when you look at this function, you can see that this is the first part of our function, the 5x squared, and the second part is going to be the natural log of x. And so to find the derivative, you just take the first part of the function, which is the 5x squared, multiply by the derivative of the second part of the function, which is going to be 1 divided by x, because remember when I talked about the natural log rule, to find the derivative of that, you're simply going to say 1 divided by x. And then you want to add all that to the second part of the function, which again is the natural log of x, multiplied by the derivative of the first part of the function. And so to find the derivative of the first part of the function, you're going to use a power rule for this, and I already talked about that, but just as a review, use a power rule. You will simply bring the 2 out to the front, multiply by the coefficient that's out there, which is 5, so it's 2 times 5, which gives you a 10. And then you're going to reduce the power by 1. So basically 2 minus 1, which gives you a 1. And so you have x to the first power. And that's really how you would go about using the product rule. So let's look at one more example. Here you have q squared times this old thing right here. And so to find the derivative of this, you're going to basically do the same thing we did the first time. And you bring out the first part of the function, which is q squared, and multiply that by the derivative of the second part of the function. And so to find the derivative of this, you're going to want to do it individually, okay? So you start off with the 2 times e to the q power, and this is basically using the exponent rule, and I already talked about the exponent rule. And so to find the derivative of this is really going to be the same thing, because if you remember from that video, the derivative of e raised to the power of a variable is going to be the same thing. So it's really e raised to the power q, and then you're going to multiply that by the coefficient that was given, which is 2. So ultimately you're going to get the same thing for the derivative. And then for this part right here, to find the derivative of this, you're going to use a power rule. And again, you say -2, bring it out to the front, multiply by the coefficient that's out there, which is 4. And so when you multiply those two things, you get -8. And then you want to reduce the power by 1. So it's -2 minus 1, which gives you a -3. And for this one, what we really have in this -q here is, let me write it out real quick. So this is really what you have, -1 times q to the first power, and you're going to use the power rule again. So it's going to, you bring out the 1 to the front, and so -1 times 1, which gives you a -1. And now you have q to the first power, and you want to reduce the power by 1. So it's 1 minus 1, which gives you a 0. Okay, 1 minus 1 equals to 0. And forgive my writing, I know it's not good. But anyway, you have a 0. So now the power is a 0. And remember, anything raised to the power of 0 is going to be a 1. So q raised to the 0 power is going to give you a 1. And so ultimately, you're going to end up having 1 times 1, which is equals to a 1, which is why it's -1, sorry. So it's -1 times 1, which is equals to -1, which is why the answer here is a -1. For the second part of the derivative, you're going to write the second part of the function. So it's this, you put it right here, and then you want to find the derivative of the first part, which is this right here. So you use the power rule, and you say 2 times 1 gives you a 2, and reduce this 2 by 1, which is 2 minus 1 gives you a 1. So it's 2q to the first power. And so that's how you would use the product rule. Now we'll move on to the quotient rule. For the quotient rule, we will be dividing parts of a function in order to get the derivative. So to solve this, you take the denominator, multiply that by the derivative of the numerator, and then subtract that from the numerator multiplied by the derivative of the denominator, and after which you would divide all of that by the denominator squared. So let's look at some examples so that all of that actually makes sense. In our first example, we have 4x divided by the natural log of x. And so to find the derivative of this, you're going to take the denominator, which is natural log of x, multiply that by the derivative of the numerator, which is 4x, And so to find the derivative of this, you would use the power rule. And we have 4x to the first power. So you take out the 1 to the front, multiply that by the coefficient, which is 4. So it's 1 times 4, which gives you a 4. And then you want to reduce the power by 1. So you have 1 minus 1, which gives you a 0. And like we said, anything to the power of 0 is going to be equals to 1. So ultimately, you have 4 times 1, which gives you a 4. And then you subtract that, and then take the numerator, which is 4x, and multiply that by the derivative of the denominator, which is 1 divided by x, like we talked about before. After that, you're going to divide by the denominator squared, so it's natural log of x squared. And so that's how you would go about using the quotient rule. Let's look at one more example. And so for this second example, we have this function right here. And so to find the derivative of this, you're simply going to do what we did before, bring the denominator out, say t minus 1, and then multiply that by the numerator, well, the derivative of the numerator. And so to find the derivative of this, you're going to want to do it individually, okay? So for the first one, we have c squared, and to find the derivative, we're going to use the power rule. So you bring the 2 out to the front, multiply by the coefficient, which is 1, and so it's 2 times 1, which gives you a 2. Okay, and then you want to reduce the 2 by 1, so it's 2 minus 1, which is equals to 1. And so now you have a power of 1, so 2t to the power 1, okay? And then for this one, you have 4t to the power of 1. And so what you're really going to do is end up solving it the same way we did this one. And ultimately, you get a 4 back. And then for this year, we have a constant. And if you remember from when I talked about the constant rule in one of the previous videos, we said anytime you have a constant, to find the derivative of that, you're simply going to say the answer is 0. It's always going to be 0. And so the derivative of this is 0, but we don't write it out in the final answer. And then you subtract, okay, and then take the numerator, just all of it. You don't have to find the derivative, okay? So it's this, but you write it back, and then you want to find the derivative of this. And so to find the derivative of this, you're going to have, well, let me write it out in full. So what you have is 1t to the power of 1. So you're going to use the power rule, okay? And so first you bring the 1 out to the front, multiply by this 1 right here, and so you have a 1. And then, sorry, you have a 1. And then you want to reduce the power by 1, so it's 1 minus 1, which is equal to a 0. So now you have 1 times t to the 0 power, and like I said, anytime you have anything to the 0 power, it ends up being 1. So ultimately, you get 1 times 1, which is equals to 1, which is why this is a 1 year. And then for this part of it, you have a constant. Like I just said, anytime you have a constant, the derivative of that is going to be equals to 0, which is why our final answer for the derivative of this is going to be a 1. And then when you're done with all of that, you want to divide that by the denominator squared. So that's why you have this. And that's how you go about using the quotient rule. Next up, we're going to look at the chain rule, and that will be the end of the derivative series. So the chain rule is used when you have one function inside of another. For example, here where you have this function a plus 4 inside of this function here, which is a cubed function. And so to take the derivative of these types of function, you have to take the derivative of the the outside function first, which is a cubed one. And then you're going to multiply that by the derivative of the inside function, which is what is inside of the parentheses. And so let's look at the example properly. Well, taking the derivative of the outside function first, we're going to have to use the power, because really this is a power, it's a plus 4 to the third power. And so like the power rule, you would bring the power out to the front, so it's 3, you bring it out to the front, multiply by the coefficient, which is a 1, although it's not written, so it's 3 times 4, which is going to give you a 3. And then, again, like the power rule, you would reduce the power by 1, so it's 3 minus 1, which is going to give you a 2. And then you would just put the parentheses the same way when you go to write it out. And then for the inside function, to find the derivative of this, let me write it out real quick. You have 1a to the first power, and this is again the power rule, so you just bring the 1 out to the front, multiply by the coefficient, which is a 1, so you ultimately get a 1. And then you want to reduce 1 by 1, so it's 1 minus 1, which is equal to a 0. And so now you have a to the 0 power, and like I said, whenever you have a 0 power, it's going to be a 1. So you get 1 times 1, which gives you a 1. And that's how you get the 1 right here. And then for the plus 4, well, it's a constant, and like I said, whenever you have a constant, the derivative of that is going to be 0. And so This is a 0, but though it's not written. And that's how you would use the chain rule. So let's look at one more example just to make things a bit more clearer. Okay. So with this example, you have 2 times, well, the square root of 5p minus 7. And yeah, we're going to have to rewrite in order for you to be able to like solve easily. And I did talk about rewriting in one of the previous videos, but I'll just quickly review on that. Yeah. And so for you to rewrite this, well, you have the square root of 5p minus 7. And really, whenever you're taking the square root of anything, you're really just raising that to the 1/2 power, like you see here. So ultimately, this becomes 5p minus 7 to the 1/2 power. And so now you can use a chain rule to solve when it's in this format. And so again, you would just take the power out to the front, multiply by the coefficient, which is a 2. So it's 1/2 times 2, which is a 1. Although I wrote 2 before, but I scratched that out, so it's a 1. And then you want to reduce the power by 1. So it's 1/2 minus 1, which gives you a negative 1/2. And again, you just put the parentheses back here. And so that's how you find the outside function, the derivative of the outside function. And now for the derivative of the inside function, you have, well, 5p minus 7. And again, you have a constant. So remember, whenever you have a constant, the derivative of that is going to be 0. And so we have a 0 for this, but you don't show it, okay? And then for this one, it's 5p to the 1 power, and you would bring the 1 out to the front, multiply by the coefficient of 5, which gives you a 5. And now you have p to the 1 power minus 1, which gives you a 0. Again, p to the 0 power is going to be 1. So ultimately, you have 5 times 1, which gives you a 5 here, okay? And that's it for the derivative series. That's how you find the chain rule, and that's all I have for you. Thanks for watching. If you like, you can go ahead and like the video. You can subscribe if you want, as well as share with anyone you think might find it helpful, and also leave a comment if you have any questions. Hopefully I can clarify that for you. And yeah, that's it.